Right, we're going to go over this test really quick. The test that you have has already been graded, so if you pass the test, I only want you to look at the ones that you missed and see what you did. So if you made a 70 or higher, just look at the ones that were counted wrong in the video. So that means that you can fast forward. If you did not pass the test, then you're going to be retesting after school. It's going to be your job to make arrangements with somebody at your house to come pick you up or take a bus home after tutoring, and you're going to come in and retake this test, and you're going to have to watch even the ones that you didn't miss to make sure that you did them correctly. You weren't guessing, because you're going to have those problems on the test too. So number one, use your knowledge of divisibility rules to find out if a number is divisible by 2, 3, 4, 5, 6, 9, and 10. Okay, so I'm going to put check marks on the ones that it is. So 144, is it divisible by 2? Yes, because it is an even number. It's an even number because the last digit is an even number. 4 is even. Remember, your even numbers are in blue on the number line and red on the number line, are the odd ones. Okay, is it divisible by 3? Well, let's add these digits together. 1 plus 4 plus 4, that's 9. 9's divisible by 3, so 144 is. For the number 4, you look at the last two digits. 44. Is 44 divisible by 4? Yes, it is. Okay, for 5, is the last digit a 5 or a 0? No, it's not. For 6, did you mark 2 and 3? Then you mark 6. Okay, if one of those was missing, then you wouldn't mark it. Okay, for 9, let's add up those digits again. 1 plus 4 plus 4 was 9. Is 9 divisible by 9? Yep, so 144 is. And for 10, is the last digit a 0? No, it's not, so 10 won't work. Okay, now let's do 51. Is 51 an even number? No, it's not. It's odd because the last digit is odd. Okay, for 3, let's add up 5 plus 1. 5 plus 1 equals 6 when you add those together. And is 6 divisible by 3? Yes. Okay, is 4, you have to look at the last two digits. And the last two digits make 51. And 51 is not divisible by 4. Because I know 48 is 12 times 4, and another 4 would be 52. That's really close. Is it divisible by 5? No, because it does not end in a 5 or a 0. Is it divisible by 6? No, because I did not mark 2 and 3, only 3. So it's not divisible by 6. Is it divisible by 9? Well, 5 plus 1 is 6. 6 isn't divisible by 9, so 51 is not. And 10, does it end with a 0? No. Number 2. Determine if the numbers are odd, even, or odd. You guys, so many of you struggled with this. All you have to do is look at the last digit. Okay, your even numbers, 2, 4, 6, 8, 10, 12, they end with a 2, 4, 6, 8, or 0. Those are the even numbers. Okay, maybe I should have written those in blue, because they're blue on the number line up on the wall. Oops, I put a 9. 2, 4, 6, 8, 10. Okay, or 0. I'm even going to get rid of that. All right, odd, every other number starting with 1. 1, 3, 5, 7, 9. Okay, so 6 is even. 3 is odd, so that makes 513 odd. 7 is odd, so that makes 987 odd. And 30 ends with a 0. 0 is even, so that means 30 is even. I don't care what comes before it. Okay, now 6 and 7. When I look at the T-chart for 10, okay, and you could have used those up on the wall. Whoops. 1 times 10 and 2 times 5. And then for 38, this is only to help you find a common denominator. If you already know the one to divide by, that's fine. Okay, but what I see here that they have in common is the 1 and the 2, and that's it. 2 is the biggest one, so that's what I'm going to divide by, and I get 5/19. Okay, with 15, It's 1 times 15, 3 times 5, and then 45 is 1 times 45, 2 times nothing, 3 times 15, and 5 times 9, and that's it. Now let's find the biggest one that they have in common. I see that my biggest one is 15. So that's what I'm going to divide by is 15. And that gives me 1/3. Okay? 15 divided by 15 is going to be the number that's across from it. 15 divided by 15 is 1. 45 divided by 15 is 3. Okay, it's just the number that's across from it. Okay, number 8. If you use the lattice method, some of you need to refigure out your lattice method or your box method or your matrix or whatever you're calling it, because some of you are doing that wrong. Okay, all I did was take 2 times 3, 2 times 1, and 2 times 2. 2 times 3 is 6, 2 times 1 is 2, 2 times 2 is 4, and then when I start my second row, I put a 0. And then do the same thing with the 1. 1 times 3 is 3, 1 times 1 is 1, 1 times 2 is 2, and then I add those together, and that gives me, do it over here, 2,556. Okay, I don't know why these lines didn't show up. 2 times 5 is 10, carry my 1. 5 times 8 is 40, plus 1 is 41. 5 times 1 is 5, plus 4 is 9. Start my second row with a 0. If I was going to start a third row, I would need to put 2 zeros. Every time you add a row, a layer, you have to add another 0. Okay, 1 times 2 is 2. 1 times 8 is 8. 1 times 1 is 1. Add those together, and I'm going to do it over here. 17, carry my 1. That's 2,730. Name the value of the underlined digit. So my trick was, and I'm going to zoom in to make this a little easier, put a 1 under the decimal and zeros under the other digits. Most of you got this one right. And stop at the underlined number, and that made a 100. So the value of that is 5 hundredths. And then the number 11. 1 0 0 0. That's 1,000. So the value is 1,000th, or thousandth. There's only one of them, so that is singular, not plural. Okay, and then I gave you a big clue on how to solve these when I said, remember, the factor tree is not the answer. You still have to write out the answer. And then some of you are doing the factor tree for 12. No, it's number 12 and number 13. All right, so for 48, doesn't matter what you start with. I'm going to start with 2 times 24, but you could start it with 4 and 12 or 3 and 16. Doesn't matter what you start with. You're going to end up with the same prime factorization. And a lot of you were including composite numbers in your prime factorization. The very first word of that is prime. Okay, so I have 2 times 2 times 2 times 3 times, oh, that's it. No, I needed one more 2, don't I? How many do I have? 1, 2, 3, 4. So I have 4 2s and then 1 3. Okay, over here for 39 is just 3 times 13. Now remember, the factor tree is not the answer. You still have to write it out. And some of you are trying to solve it. No, 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 no. Just write it out like that. Those are your factors, and they're all prime numbers. We don't need you multiplying them out in the middle. You can check it at the end to see, okay, is that really equal 48? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. Yes. But you don't solve it in your answer. Okay, that's the end of this test.